Now the next problem in the second bit. So this is the problem. The function is in terms of here cos is given. So first going to this one. First I am taking what is the given here in the solution. So let I am taking as a or I. So 0 to pi by 2 sin phi x by sin phi x plus cos power phi x dx. Okay, and we know what is the formula. This type of problem you have to solve by only. So 0 to a f of x integration is we have 0 to a f of a minus x integration. So upper limit is a. So in place of f of x you have to substitute here a minus x. So this is one of the property. So with the use of this property only you have to solve this one. So for that I am taking. So therefore 0 to pi by 2. What is given? Sin power pi x by sin power pi x cos power pi x dx plus, and this is a equal to 0 to pi by 2 a minus x. A is one nothing but here pi by 2 we have. So then what will get here? Sin pi by 2 minus x by sin pi by 2 minus x plus cos pi by 2 minus x dx. So what we taken here? A. Okay, a is equal to, in place of x, a minus x we are taking. So then this is nothing but here, what is the 0 to pi by 2 here? Sin power pi by 2 minus x, sin 90 minus theta cos theta. So then we'll get here only cos power pi x, and this is a sin 90 minus theta cos theta, for that cos pi x only, and cos 90 minus theta sin theta, sin cos sin pi x dx. This is a also. So this is the second equation I am taking. This is the first I am taking here. So to evaluate this one, now what I am doing here, 1 plus 2 I am taking. So in the left side a, here a. So a plus a plus a. In the first equation, the right side we have 0 to pi by 2 sin power pi x by sin power pi x cos power pi x dx, and plus the second equation 0 to pi by 2 cos power pi x by, so a plus b can be written as b plus a. So first I am writing this one. So sin power pi x plus cos power pi x dx. So a plus a is a 2a will get. So this implies a plus a is a 2a. So observe here, we are integrating with respect to x, both are function and the limits are also same. So therefore we have integration of f of x plus g of x. Whenever integrating with respect to x and the limits are same, then it can be written as integration of f of x plus g of x. I am combining this inner function. So then we'll get the 0 to pi by 2 sin pi x, and the LCM is also in the denominator both are same. So then what will get here? The denominator sin power pi x cos power pi x. So when both are same, just we have to add the numerator. So this one plus this one plus cos power pi x dx. So observe, the numerator denominator both are same function will get cancelled. The remaining is 2a is equal to only 0 to pi by 2 1 integration. So 1 integration is a x, the limits are here 0 to pi by 2. So now you have to substitute upper limit minus lower limit to get what is the 2a value. So pi by 2 minus 0. So pi by 2 minus 0 is only pi by 2 only, but you want here a. So a, when I take into this 2, when I take into this side, we'll get a equal to pi by 4 answer. So a what we taken? So therefore a is nothing but 0 to pi by 2, that is a sin power pi x, and sin power pi x plus cos pi x dx. This value is how much you got here? Only pi by 4. Now the next one, evaluate integration 0 to pi by 2 sin square x minus cos square x by sin cube x plus cos cube x integration. So then this is also one of the trigonometry, so that's why directly it's not possible here. So we have the possibility. What is the possibility? What is the t is equal to tan x by 2, t is equal to tan x by 2, and like that you have to take here. So both side derivating here. So dt is equal to, so that is sin cos dx. These three terms you have to convert into t terms, and when I converting into t terms, we'll get this is a algebraic function. So that is in the indefinite integral we saw the in the special methods. So trigonometry we converted into algebraic, and algebraic you have to solve by any one of the method or principle. So otherwise we have to directly also we have to solve this type of problems. So going to solving, first I am taking what is the given. Let a equal to 0 to pi by 2 sin square x minus cos square x all by sin cube x plus cos cube x integration. For our convenience I am taking as a 1 year. So we have, what is the formula? We have 0 to a f of x. Integration is 0 to a f of a minus x dx. Upper limit is the a. So in place of x we taken here a minus x. We have the property. So from this I am taking what is the 1. From 1, a is equal to 0 to pi by 2 sin square x minus cos square x all by sin cube x plus cos cube x integration is upper limit is a pi by 2. So a unte a minus x, upper limit pi by 2 got pi by 2 minus x time. So 0 to pi by 2, so sin square x is a pi by 2 minus x minus cos square pi by 2 minus x all by, as well as in the denominator also you have to convert. So sin cube x is nothing but here a minus x, that is a pi by 2 minus x minus plus cos cube pi by 2 minus x integration is the same. So with the use of this property only. So then this is nothing but 0 to pi by 2 sin square pi by 2 minus x. Pi by 2 is a 90. Sin 90 minus theta cos theta. So then sin square will get as a cos square x, and cos 90 minus theta sin theta. So this is a sin square will get. Here also sin cube 90 minus theta sin cos. So cos cube x plus this is a sin cube x will get. This is a. For our convenience I am taking as a second equation. So I am to evaluate this one, I am taking 1 and 2 adding here. So now I am taking 1 plus 2. So 1 plus 2 is, so in the first equation left side we have a, in the second equation left side is a equal to, first equation right side is we have 0 to pi by 2 sin square x minus cos square x whole by sin cube x plus cos cube x integration plus here 0 to pi by 2 is this, and this is a cos square x minus sin square x whole by cos cube x plus sin cube x integration. So this we taken, but is a 1 plus 2 only. So left side and the right side. This is a plus a is a 2a, and observe integrating in the both terms we have integrating with respect to x, as well as we are taking the integration upper limit and the lower limit is also same. That is integration of two terms is integration f of x plus g of x can be written as f of x plus g of x. So for that 0 to pi by 2, what is the here sin cube x cos cube x cos cube x sin cube x, both are same the denominator. So when adding these two we'll get sin cube x cos cube x only. So when the denominator both are same, just adding the numerator. Numerator is what we have here, that is a sin square x cos square x plus cos square x minus sin square x dx to dx. So sin square x with positive negative, cos square x with positive negative. The remaining in the numerator 0, nothing we have. So that's why 0 by something is a 0. So then this is 2a equal to 0 by something 0. So then 0 to pi by 2 and 0 integration. 0 integration is totally 0 only. So then you want a, so a is nothing but here 0. So therefore a what we taken here, the given one, 0 to pi by 2, what is the sin square x minus cos square x whole by sin cube x plus cos cube x. Integration is we got here 0. Okay, this is very simple method when using the this property 0 to a f of x integration is a 0 to a f of a minus x. So this problem you can solve by, so t is equal to tan x by 2, may be very difficult and very length also. Now the next one, evaluate limit n tends to infinity root n plus 1 plus root n plus 2 so on plus root n plus 1 by n root n. We given the limit of a sum. So limit of a sum unnadani we have to evaluate. So we have the property, what is the fundamental theorem of the integral calculus, first fundamental theorem. So integration 0 to p f of x, integration 0 to p f of x can be written as limit n tends to infinity 1 by n summation I is equal 1 to np f of I by n. So we taken this property so to solve in the first exercise, and when you given this type of problem, so we converted into this one, after that we evaluated. So that is integrals can be written as, can be evaluated by limit of a sum. Now we given limit of a sum, so this type of problem you have to convert into the integrals, and after that integrate and the apply the limits, upper limit and the lower limit. So for that, so the given you have to convert into this one, after that you have to convert into this one, and after that you have to find the integration. So for that I am taking what is the given one here. So this is can be written as, what is the can be written as limit n tends to infinity root n plus 1 n plus 2 so on n plus n by n root n. ఇక్కడ మనకు 1 by n అనేది కామన్ కావాలి కాబట్టి, so this n 1 by n, this n I am taking outside, that is separate I am taking here. So limit n tends to infinity 1 by n, and the remaining is here, when I am taking 1 by n, the remaining is root n plus 1, root n plus 2 so on root n plus 1 by root n we have. So then this is nothing but here, when I am taking from this one also, root n taking common in the first term, when taking root n common, then what will get here, 1 plus 1 by n with root, plus here also when I am taking root n common, here what will get here, 1 plus 2 by n with root, plus so on. Here also root n I am taking common, then what will get here, 1 plus n by n with root, whole by, already we taken n taking common, here root n. So here I am not n by n I am taking as a 1, because we want the form of here summation form, so that's why I am taking as this. So here in the first term, second term, in the nth terms also we have the root n, so that's why taking outside here the common limit to n tends to infinity 1 by n of, so root n total common. So when taking root n common, then what will get in the numerator, 1 plus 1 by n with root plus 1 plus 2 by n with root plus so on, plus 1 plus n by n with root, whole by root n. Root n cancel, root n cancel. The remaining is limit n tends to infinity, and we converted into 1 by n, limit n tends to infinity 1 by n, and this you have to write in the summation form, summation. So here what is the here, 1 plus 1 2 3 so on, 1 2 3 up to so on n. So here only changing, that's why I am taking as I by n with root to root. root, where I is equal to 1 to up to so on. How many terms we have here? N terms we have. N terms 1, 2, 3, so on, n terms. So therefore this is I am taking as a limit n tends to infinity 1 by n, and summation I is equal to 1 to, this is a form of here function of I by n. So whenever the function of I by n you have to take into f of x. So f of x is nothing but 0 to 1, 0 to 1, f of x. F of x is nothing but here f of, in place of here I am taking 1 plus x, 1 plus x dx. So then this is nothing but here 0 to 1. So that is nothing but here 1 plus x with root dx to dx. 1 plus I by n plus lo x, I by n plus lo x ఉంది కాబట్టి, so then I am taking 1 plus x. So root x integration is x power 3 by 2. We have the formula. So root x integration, what is the here? X power 3 by 2 by 3 by 2 plus c. So then 2 by 3 x power 3 by 2. 1 by 2 plus 1, 3 by 2. So then this is nothing but what will get here? So 1 plus x whole power 3 by 2 with 2 by 3. The limits are here 0 to 1. Upper limit minus lower limit. So then what we get here? This is 2 by 3, and the upper limit is 1 plus 1 whole power 3 by 2, and minus lower limit is 1 plus 0 whole power 3 by 2. So 2 by 3 here. So 1 plus 1 is 2, 2 power 3 by 2 minus 1 power 3 by 2. Only 1 plus 0 is 1 only here. And this is 2 by 3, and the 2 power 3 by 2, 1 power something is only 1 only. So therefore 2 by 3, 2 power 3 by 2 minus 1. Okay. See this one, what he given, once again telling you. So when he given the limit of a sum, you have to convert into integrals form. After that only evaluated integrals. So in the previous exercise, when he given the integrals, we converted into limit of a sum. After that we evaluated that one. So that is a small difference. Now the next one, this is also same thing here. So limit n tends to infinity 1 by n plus 1, 1 by n plus 2, so on plus up to so on 1 by 6n here. So this is also a given limit of a sum. Limit of a sum terms is given. So you have to evaluate. So this type of problem also, limit of a sum when is given. So this problem you can solve by integration also. So that is nothing but this type of problem you have to convert into the integrals form. After that you have to integrate, and the upper limit and the lower limit you have to substitute here. So for that I am taking, so what is the given? Given this one, this is 1 by, sorry, limit n tends to infinity. So in this one you have to take what is the 1 by n common. So 1 by n బయటికి రావాలి కాబట్టి, so from this the first term also n taking common, 1 plus 1 by n plus n common కావాలి కాబట్టి n బయటికి రావాలి కాబట్టి n taking, and 1 by here also n taking common, 1 plus 2 by n and plus so on here. So we want here n plus 1, n plus 2, so on here 6n కాబట్టి, so then this can be written as here n plus 5n, the last term here. So here also when n taking common, what will get here? 1 plus 5 by 5n by n, 5n by n. Okay. So this is I am writing because why we are taking here, we want 1 by n common. So that's why limit n turns to infinity. So in the first term we have 1 by n, in the second term, in the every term we have 1 by n. So taking common here, the remaining is 1 by 1 plus 1 by n plus 1 by 1 plus 2 by n plus so on plus 1 by 1 plus 5n by n. Okay. I am not cancelling here, n cancel, we get 5. So because we want how many terms we have, n terms or 2n terms or 3n terms or 5n terms. So that's why I am not cancelling this one. So then this is limit n turns to infinity 1 by n, and this is a summation I am writing here. So what is the form? 1 to 1. In the numerator all are 1. In the denominator also first term we have 1, and here the denominator n also we have n, and 1 2 3 so on only changing. That's why I am taking here I. So where I is equal to 1 to 1 2 3. How many terms we have? 5n terms we have. 5n terms we have. So therefore this is we converted into limit n tends to infinity 1 by n summation f of I by n. So this is can be written as like this. So integration this one. So therefore this is 0 to p. So p is nothing but here what is a 5. So we want here I is equal to 1 to np అంటే p np. సో p ప్లస్ లో మనకి ఎంత ఉంది ఇక్కడ 5 ఉంది కాబట్టి సో 0 to 5 f of x అంటే in place of x we have here I by n. సో కాబట్టి 1 by 1 plus x integration to integration. In place of I by n, you have to take with x only. So then 1 by 1 plus x integration don't know, directly don't have. So 1 by 1 plus x square integration we have. So for this don't have. So I am taking this is as 0 to 5 1 plus x 0 to 5 1 by 1 plus x integration. Zero to 5 1 by 1 plus x. So this is I am taking, and this is a whole I am taking as a capital X. So capital X is equal to 1 by 1 plus x. When I derivating dx is equal to 1 derivative 0, x derivative is a dx. And after that see the limits also you have to, because here so this whole thing I am taking as a in terms of capital X here. So that's why when I am changing into other variable, so you have to change the limits also. So now you have to check this is the changing or not here. So when I taking here x equal to lower limit 0, so then x equal to when I taking here 0 will get here 1 only, and when taking upper limit 5, so 5 and 1 plus 5 is 6. So then when I taking here 0 to 6, sorry here 1 to 6 we are taking 1 by capital X is nothing but here 1 plus x in place of we taken as a x. So dx is a dx, and small x I am converting into capital X form here. So then what will get here 1 by x integration is a log x. The limits are here 1 to 6. So 1 to 6 is upper limit is what is a log 6 minus log 1. So then this is nothing but here log 1 is a 0. So therefore log 6 is a answer for given limit of a sum.